Module 2, quadratic functions. Quadratic meaning the higher power of 2. To begin Module 2, we're going to talk about the graphs of quadratic functions. So Objective 1 for this video will be an introduction to graphs of quadratic functions. A quadratic function can be written in the form ax squared plus bx plus c, where this is considered to be standard form. Please label that. Standard form. Where a, b, and c are all whole numbers and considered to be coefficients. You will hear the word coefficient a lot this semester. The graph of a quadratic function is called a parabola. So, to begin, there's key features of parabolas. The U-shaped things or the smiley faces that you see. We're going to take notes on what all the key features are, and then we're going to practice step by step how to find all of these key features algebraically. So, back to standard form. A, B, and C. Again, those are all coefficients, meaning they're all being numbers at some point. So in A, the leading term is positive. The parabola opens up, meaning it makes a smiley face. When A is negative, so a negative number out front, the parabola opens down, makes a frown face. That's how I remember it anyways, a smiley face or a frown face. So positive people are happy, they smile a lot, meaning their cheeks will open up, same with the parabola. Alright, so far so good. Let's keep rolling. The first and biggest thing, this word right here, the vertex. The vertex is the beginning point of any parabola. It is either the highest, depending on if it opens down, or the lowest, opening up. So it's either the highest, the maximum, or the minimum point of a parabola. So you need to be able to tell me every time, like for example, on the left over here, the vertex is right here. So it is 2, 1. The vertex is 2, 1 here. So you need to be able to tell me that that maximum, if this was a projectile and it traveled up, hit its maximum point right there, right here, you need to tell me that that maximum point is the vertex of this graph. Down that, and then if it started to fall after that, you need to be able to make the connection that the vertex and the maximum, or the vertex is the maximum or minimum depending on the graph. So, carrying on, the vertex is on what's called the axis of symmetry. Axis of symmetry is a vertical line that splits the parabola into two equal halves. So, in this case, I already identified this vertex to the left as 2, 1. The axis of symmetry is always the x value of that vertex, so x equals 2. So this is split in half at x equals 2, an imaginary line that exists right here. That is the axis of symmetry at x equals 2. If you're given an equation, so this is giving you a picture, it's easy to see via picture if that is already given to you. But if you're given an equation for a parabola instead of a graph, you need to do some algebra to figure this out. You need to use the equation x equals negative b, opposite b, over 2a. You need to write that formula somewhere nice and big so you can reference it. Negative b over 2a. It's always, by default, opposite b, so that negative will always be there. That finds the x value, or the axis of symmetry. And then to find the y value, or the other piece of the vertex, so let me finish this. It will have, the axis of symmetry will be at negative b 2a over 2a. When that finds the x value, or the axis of symmetry of the vertex, then you plug this x value back into the original equation to find the y value of the vertex. And we'll practice that moving forward. But that is a very important formula, this vertex formula, so please make note of that and remember that. Now, two other pieces of information that matter about a parabola. The y-intercept. The y-intercept of a parabola is where the graph crosses the y-axis. The y-intercept always has an x value of 0. So for a parabola, what that means then is they're saying that if I input, like let's look at this graph. This crosses the y-axis at this point here. This is the vertical axis. That point is 0, -3. So the y-intercept will always have an x value of 0. So if given a parabola, or given a function, let's move up to the standard form. To find the y value, or to find the y-intercept, you put 0 in for the x's here and here. That would make the a term and the b term 0 because they're being multiplied. So all I'm left with for my y-intercept, the y value, it will be whatever c is, whatever that number c is from your original function. So it will be called 0, whatever c is. We'll practice that in a little bit as well. And then finally, the x-intercept. Scoot this down just a bit. The x-intercept, or where they cross the x-axis, to find the x-intercepts of a parabola, you need to factor the quadratic. Once you've factored the quadratic, we're going to practice that a lot moving forward in Algebra 2, the rest of it. You set these factors equal to 0 and solve for them. Solve for the x's. Your solutions represent the x-intercepts. Or, more specifically, where the parabola crosses the x-axis. We answered this in a warm-up, but a quadratic, highest power of 2, will always have 2 solutions, or 2 x values. That is the introductory notes. Now we'll move into actually putting this into practice, the algebra pieces of everything.